Okay, welcome to the next video in the Systems Programming video series, continuing with assignment 5, the part 4 about writing to a file and then glitching it. So we've just been able to, open the file, write a first line, and now we'd like to write the rest of the file. In order to do that, next what we have to do, because like if you think about how a file is supposed to look, we don't need this comment, so we can skip that, but we do need to write the dimensions of the pixel map. And then the question is, how do you use fwrite to write a number, right? So, right, like something that's in a variable, because these are not formatted strings, so we can't use the %d trick. So we could say char star line equals malloc size of char times, and I'm going to say max, whatever that thing was, max, oops, line length, okay. I think that's, and I guess I could say like that +1, right? Not that I think we'll even get close to the max size, but and then I can put in the line whatever I want to write. And so for that, I could use sprintf, right? String print format. So now I can use my %d, %d coming from w and h. And then I can take that and fwrite it. And so I want to do size of char, and I want to do that how many times? Oh, and I probably want to put my line break in there. I suppose I want how many chars max. Now that gets me that. Then I want to say fwrite, and then I just want to say 255 line break for the max RGB value. Oh, there are 4 characters because 3 text and a line break, and then fp. And now I want to write the data. So how do I write the data when it is all in this PXS passed in matrix of whatever ppm pixels? Well, presumably we simply fwrite. So if we fwrite the entire pointer, which would be PXS, and the size, so let's say the size of a single pixel that I'm going to write with its binary data, which would be size of struct ppm pixel, and how many of them w times h, and where does it write to, fp. And that should, now this is not what the assignment asked for because this is just directly writing the, but at the very least, like the demonstration that I am able to write the pixels is a nice demonstration. Oops, I'm missing FP up here. So if I did this, then the glitch file should contain basically a copy of the source file, so to speak, anyway, the original file. So let's test that out. Make doesn't like something. sprintf w is an int. Oh, right. I never gave it the string to print to. So how does that go? What's the first thing that it likes? It likes, okay, so the string to print to, which would be line, and then I pass in the rest. That works. Okay, it wrote the file. Let's come over to the glitch, and that's not correct. Why did it write all these lines of null? So it correctly wrote the dimensions, but it did not correctly write, right, between writing the dimensions and writing the max color value, it put a whole bunch of nulls in there, and I don't know why. So, oh, and I should make sure that yeah, I think I did. Okay, one thing I should do is say if bang line, or should I error? Let's just do an error message. So right, not that this really matters. And what else? So, and then I need to free up before I exit. But anyway, none of that's going to fix this problem. So, oh, I wonder if it's because, oh, did I? Oh, yeah. Well, no, char. It's, yeah, it's probably due to this max line length. Right, and of course I should instead use Sterling to determine how many writes I'm going to do, which is 1. That seems good. Try it now. Yes, that looks right. Okay, cool. So we seem to have written the file exactly. Now let's glitch the file. So um, before writing this, instead what we want to do is maybe like a for loop. Int I equal to 0, I less than, this is the rows, so hi plus plus. So let's get the pixel. So this would be like struct ppm pixel, let's say p equals, and I'm going to pull from the matrix, so that's going to be, did I? Yes, pxs at coordinate I times the width plus j. So I have my pixel, and by the way, remember I said earlier that I was going to use this union structure, and in one place I'm going to use it as an unsigned char array, and in another place I'm going to use it as a struct with pointers. And that's what I'm about to do now. Because what I did when I used fread, right? Because I was using fread, I simply like filled, just all the coordinates of the array essentially. Uh, Although honestly, is it any more when I did the fread, did I any more use it like this than I used it like that? I don't know. Yeah, but I am now, yes, and since, maybe I used it like this, maybe it kind of equivalently was used like this. But in any case, I am now going to use the fields of the struct, and therefore I am going to explicitly be using this part of the union to help me to accomplish the behavior that I want to accomplish. It could be accomplished in other ways, but this is convenient. So what I want to do is maybe I want to say that int red, or why not just r, equals p dot red. In fact, actually, could I write? Yeah, maybe I could just simply write fwrite. Oh, but may I need the, okay, so let's say, yeah, let's just say fwrite, and it's a void star pointer, so it doesn't have to be a string. But yeah, let's just put this in a string. So in fact, I don't need a full string. I just need an unsigned char because each pixel value is only going to need that much space. So let's say unsigned char color or something like that. And I think I want to initialize this as 0. And then when I grab the pixel, I want to get the color. So I want to basically make color equal to p.red. So that's where I am using the part of the union structure where I'm calling the field pointer. So unlike using it as an array, I get to use it like a struct. But I could use it like an array if I wanted to. Okay, but I want to take that, bit shift it left, this is what the instructions for the assignment said to do, by either a random 1 or 2, a random 1 or 2. So let's say rand mod 2, but then I want to do +1, and let's make sure that it groups parentheses correctly. So that is my red color, and so I'm going to write. Now I want that color in a string. Oh, right, but it's an unsigned char. So, oh, but maybe I should make it a pointer so that I can cast it to void. So if I said cast to void star, because I think when you're not dealing with a string, it wants to have this cast to a void. So anyway, void star color. Size 1 byte, an unsigned char should be 1 byte. How many of them? Just 1. And then file restrict, write is the file to write to, of course. And so that's what I write. And then I basically just keep doing this for each of the other colors. So I might as well copy this and do it 3 times, just editing. So green. I could have done this in a for loop if I treated it like an array, but I'm not going to worry about that. And I guess, well, all I have to do is edit red, green, blue, right? And then it'll just write that in a loop. And I don't know that there's anything else I need to do. Let's see what would happen if I simply did that. Ooh, doesn't like something. Oh, it might not like the parens, I think. Oh, right, and it's a pointer, so I need to deref the pointer. And I guess that's that. That looks good. It runs, but it ran with a segmentation cord. Oh, and I probably should free the pointer. Oh, right. I should no longer be writing this. That's probably causing some problem. Let's see what happens. Oh, the point. Oh, oops, oops, oops. When I initialized this, I made the pointer inside. Let's see what happens. That shouldn't have messed anything. Oh, I never malloped. Yeah, of course, right. Oops, dumb mistake. Okay, that looks, I think, pretty good. Yeah, and it looks like it's maybe somewhat randomly manipulated. So yeah, now let's test the same thing out, but instead on the Mona Lisa, generated a new file. Ooh, but something's not right. Seems like this is probably a mistake from the read part of the assignment. Oh, I just misspelled the files. That. Oh, okay. That's what it was. I just misspelled the file. Oops. Which, if I had been checking for null pointers, then that would not have confused me. But okay, yeah, this looks fantastic. So yeah, the header looks all correct, and I don't know if the data looks right, but what happens if we pull up GIMP and we open the file? Okay, so let's open, where did I put this? Desktop assignments, A5, Mona Lisa glitch. Ah, it looks exactly right. Very good. Okay, I guess that means end of the assignment.